Today's POTD maximum dot product of two subsequences, and given a two array, return the maximum dot product dot product is important point. Dot product between nums any non-empty subsequences of nums1 and nums2 with the same length. So here the question is, what is subsequence? So here we can see what is subsequence. Subsequence of a string can be written as, if you want a subsequence of nth one, it can be GEXC. It should be in order wise. Suppose A1, A2, A3, A4 is there, or string is there. So we can select any of these string elements, but in the same order. Okay, so for suppose length one is there, we can select for G, E, E, K, S. Okay, but if for length two only two cases are there, GE, then we can take GE, then we can take GK, then we can take GS. So it should be same orders. Of order 3 we can take GE, then E, K, S, then GE, then DC, then KS, like that. Okay. So here he's saying like we have to take dot product of suppose nums1 subsequences this, nums2 subsequences this. So what is dot product? Suppose A0, B1, A2, B0, B1, B2, and it should be of same size, no? Subsequences. So what will be their dot product will be A0, B0 plus A1, B1 plus A2, B2. For example, they should multiply. Okay. So now we have to find the maximum dot product of any non-empty subsequence. Okay, so we have to find max dot product of any non-empty subsequence. It should be not empty. Okay. So it should not. So how we can find it? Suppose we are given nums 1 is 2, 1 minus 2, 5. Nums 2 is 3, 0 minus 6. And what are the lengths? How much we can write it is n and m means the size of the first n character, and n means size of the num1's array, nums2 array can be n and m, and they should be 1 to 500. Okay. So what I was thinking was we can do this question directly by recursion. So now we will see how the recursion will work for these questions. Suppose int solve is there, so it will return solve ig. It will return the max dot product. So what we can do, if suppose I and j are the pointers for now. Suppose it is 0, 0 for now. So we will take dot product of these two numbers, like 2 into 3 plus. Now we will ask our solution to get this by solve of 1 comma 1. Okay, so we will ask our solve functions to return what will be the maximum sum. What if this become less than 0? but our this product was bigger than 0. So if we will add less than 0, then it will not be always be maximum. So what we will do, we will ask if is it less than 0 or not. If it is less than 0, we will add directly 0 only, because we have get the answer. So it is I plus 1, j plus 1. Okay. What if we skip num2? Suppose we have skipping num2 only this point. I don't want this. I will take our room width like this. See, what if I want to skip this number 3? I can go like this also, no? For getting the subsequence. So I can take like this can be solve of if I am skipping num2, so nums1 will pointer will be there only, and I can skip nums2 by just adding j plus 1. Okay. And similarly for nums1, I can take like this. We can skip nums1 by I plus 1 and j. Okay. And what we have to return for that? The maximum of these three. So max of these three we have to return in ij. If I is greater than n, or j is greater than m, what we will return? 0, because it will be out of bound. So this is the recursive approach. Okay, I will show you the code. Code is I comma j comma a comma b. If I is a dot size and b return, we will return the minimum int minimum, not the 0. Sorry, here we will return the int minimum because we will pass in the smallest value. No, we should pass because 0 is the maximum value. We should pass the smallest value. Why divided by 2? Because it if we will not do divide by 2, then int minimum plus int minimum become overflow. That's why here. Okay. So in take we will do a into b plus solve I plus j like 1 this condition. But here in this code 0 is not right, but this condition should be satisfying. Okay. We will skip num2. We will skip num1. So this is the recursive approach. Now we will see how the tabulation works for here. We can memorize it just by adding ing to map. Like here we will add like equals to dp of ij, and here we will say if dp of ij is not equals to -1, so we will return this value. If it is equals to -1, we will take this loop only. This is memorization part. Okay, now we will see how the tabulation will work. In table dp, what will tabulation dp, what we'll do, we will do nothing. We will think that dp of ij has all the answers of previous. Suppose we are having 0, 1, 2, 3, 0, 1, 2, 3. So what is our name for now? Suppose this is dp of ij. So if I am considering this dp of ij, so dp of ij has all the solutions. What will be the maximum dot product before that? Okay, I will explain this table afterwards. But for now, consider if we are taking this I, this is j. So I have the answer for dp of ij. Let us consider that. Let us think like that. Okay. So if dp of max product till ij is there, okay, let's suppose either we can on tabulative as we have listened the as we have think in the tabulative what was the first condition. Recursive dp was we will keep I one time, second time we will skip j to get the answer. Third time what is what the we will take nums of I into nums of j for dot product plus dp of solve of I plus j was there. But here we are coming from up. So for here, what will be the answers? We will see if it is greater than 0 or not, because it is considering, it is having that all the maximum sum whatever is 0. If we are taking this, so our equation will become dp of ij will give us the maximum. What will be the maximum in if we skip I part, j part, I part. What if we skip j part, and if we are taking nums of I into nums of j as the dot product, and 0 if the dp of I minus j is greater than less than 0 or what. If it is less than 0, we will return 0. So these are the main conditions. So we can see our code here. I have taken n to m dp. I have put n as n plus 1 to m plus 1 as int minimum. Why I have added int minimum? Because it should be less than means we can multiply any number with any now, so it can the sum can be negative also. That's why for getting minimum it should be into minimum. Okay. So what is the current product? Nums of I into nums of I minus 1. Why have done like I equals to 1 to j equals to 1? Okay, we can correct up left. What will be the product? The current product comma up left right and current product plus maximum of 0 comma dp of I minus j. But this condition can be satisfied with this, so we don't have to write this. We can directly write up left current product plus maximum. Okay, thanks.